The ancient Indian epic of the Mahabharata describes sky-darkening flying machines known as Vimanas that fought in its most legendary battles. For centuries, these descriptions were categorized as pure mythology, but the discovery of a specific technical manual forced a reconsideration of that timeline. The Vaimanika Shastra is a dense, quantitative text that details the construction and operation of these ancient aircraft. The manuscript provides a systematic breakdown of hardware, including exact metallurgy recipes for alloys and strict protocols for pilots regarding their diet and clothing. If these engineering details are verified, it would prove that ancient civilizations developed the mechanical capacity for flight thousands of years before the modern industrial age. Operating a Vimana required rigorous physical preparation. The manual mandates specific diets and heavy garments designed to protect the crew from the changing temperatures and pressures found at high altitudes. Pilots were required to master 32 distinct rahasyas, or operational principles, that governed everything from basic navigation to advanced aerial combat. These principles include mantrika, the pursuit of a structural indestructibility, and Virupakarana, which describes using smoke and mirrors to project terrifying holographic shapes into the sky to disorient an enemy. The propulsion systems described are equally complex, detailing power sources that utilize electric fields, solar energy, and the properties of mercury, referred to in the text as rasam. These descriptions often blend technical observation with alchemy, such as instructions to cook monkey skin and sea foam with precisely 16 measures of donkey's urine to create a vaporized fuel source. The resulting vision of aviation is so intricate that it requires modern aeronautical review to separate the advanced electromagnetic concepts from the era's mysticism. In 1974, a group of aeronautical scientists at the Indian Institute of Science subjected the text to a rigorous technical evaluation. The study focused its engineering analysis on one of the most detailed aircraft in the manual, the Rukma Vimana. This schematic of the Rukma Vimana reveals the design the scientists evaluated, a structure with distinct tiers and integrated propellers. When reviewing the measurements, scientists noted the immense bulk of the craft, including tiers reaching nearly 15 feet in height and a massive 80-foot base. The analysis concluded that while the ancient authors focused heavily on propulsion and massive structural supports, they completely omitted the basic physics required for aerodynamics. The manual treats the aircraft as a static structure, similar to a temple or a multi-story building, rather than a vehicle designed to generate lift. Under the laws of physics, these specifications are non-functional. A craft built to these exact instructions would be unable to leave the ground. While the Vaimanika Shastra fails as a functional engineering blueprint, it remains a significant document in the history of predictive imagination. It shows that centuries before the first successful flight, human thinkers were already theorizing about stealth technology, electronic countermeasures, and multi-stage engines. The Wright brothers eventually solved the specific mathematics of lift, but the authors of the Vaimanika Shastra had already conceptualized the mission. These ancient texts demonstrate that early civilizations were attempting to reverse engineer the very idea of flight, using the only vocabulary they had, alchemy and mysticism. The conceptual leap from the mercury-fueled Vimana to the modern space shuttle represents a single, continuous effort to overcome the constraints of the Earth.